Good evening, everyone. Myself, Anish, and share my thoughts on day two of CCNA journey at some networks, where they thought about circuit switching, packet switching, traffic flows, like how the data flows, and different IP address, version 4, broadcast domain. So let's start with circuit switching. Circuit switching is nowadays common. Using that technology, it's older based technology. It is nothing but it refers as it creates a temporary and a dedicated link of fixed bandwidth application inputs. And packet switching. Packet switching is nothing but it transfers the data over the digital networks by breaking down into packets or blocks for essential transfer of data. Like suppose if you are downloading any, it contains 1,000 like GB. So if you are downloading, you can see that top of the your mobile 10% downloaded, 20% downloaded, 30%. So it break down that 1 GB into 10 parts, like 10 packets. So it can easily transfer, it can easily download the data a simple way, essential way. Like uh, now if you are sending any message, the message will break down in packets, different packets for completion of the transferring packets and receives the data. So it won't send the data directly, it will break down the message in packets, then transfer essentially. And traffic flow it's nothing but how the data flow in different ways. Like it has type three types: unicast, broadcast, multicast. Unicast is nothing but one-to-one device, one-to-one communication. Like if you send any data to one device from one device, it will another end also it reaches only one device. It won't sends to the multiple devices. And coming to the broadcast, imagine a switch. It is a 48 switch. If you are connected, uh, if you send a broadcast frame to the input, then it will send that a copy to all the remaining ports. Like it will broadcasting domain, broadcasting domain means it will send all the copy to each and every port that switch. Like if I conduct any meeting, there are 40 students in this meeting. Imagine I'm the one delivering the content, everyone listening that. So they are receiving a copy of that which I delivered the topics. This is the best example for broadcast domain, like messages. And coming to the like broadcast always sends a data, sends a broadcast frame, and it contains a destination MAC address with FF like that, because it's hexadecimal, right? F is the last number, so it contains the destination address FFF. And if the switch receives the frame with this MAC address, then it won't respond that exact where we connect that port to won't respond. Remaining all it will sends a copy to it. But except that remaining ports will get the copy of that frame. So and for stopping this flooding out of all flooding out of this copy to all the ports, we can use routers, because routers doesn't flood out it uh, to the any PCs or devices. Suppose consider a switch, it contains three pieces. At the Ethernet contains a MAC address as I earlier said, so it will send the copy to all the remaining ports. And the switch, whenever we connect to the router, it doesn't. If router contains PC4 and PC5 and other two PCs, and the router that Ethernet data MAC address, it doesn't send to the PC4 and PC5. It stops it because router doesn't flood it out to the Like what? Um, routers doesn't flood broadcast frames. Only stop that frames. Is the way we can stop that flooding out of the broadcast frames. All the ports. But another process is there with help of virtual LANs. We will discuss it in future sessions. As of now, I don't mention there. As of now, I know this only. For broadcast, it will broadcast frame. It will spread out all remaining ports, and Ethernet cable contains a MAC address, MAC destination address. It's something but FF switch. Switch again receives that broadcast frame with the same MAC address, except that port. Remaining all ports gets a copy of that data, copy of that broadcast frame. Yeah, and coming to the multicast messages is nothing but if I conduct any, like I will conduct both freshers and experience. I will, whenever I want to deliver any something about freshers only, so the freshers only will listen. Like this, multicast only sends the data for reserved one or separate group of people or group of devices. Like that, it will send that. This is the way. Simple words, one unicast nothing but one-to-one communication. Broadcast nothing but one-to-all communication. Multicast is nothing but one-to-many or several communications for reserved candidates or reserved groups like that. And coming to the collision domain, like best example for is hub. In olden days, we can see now no one using that hub. It will work. Suppose if you imagine a hub which will connected two PCs, PC1 and PC2, and you want to print one data. You connected one external printer, so you want to print your resume. So hub is a layer 1 device. It only understands that binary raw data like bits, zeros and ones. So it will take that zeros and ones, the form of the data like bits. It will print the data from to the printer, like PC1 sending that raw data to the hub. Hub will send to the PC2 also, but it doesn't respond, and again it sends to the printer. It will print the data, like it will give the output. Again it will come back to the hub. Like if you suppose you want to print two resumes from the two devices at the same time, like two pieces. If you send that raw data to the hub, and it will go to the printer, and it will come back. And at that time, PC2 also sending one raw data like bits. Whenever the data coming back from the printer to hub, PC1 data, and the PC2 data also going from the hub to printer. At that time, they will both collide. This is called collision domain. Whenever the data collides at the same time, it refers as a collision domain. And coming to the network topologies. Topology is nothing but bunch of devices. Defines how they interact with each other. And types of network topologies: bus topology, star topology, mesh, tree, point to point. These type of topologies are there. And ring topology is also there. Nowadays we are using ring topologies and mesh topology and point to point. Point to point is linear connectivity. Ring topology is nothing but imagine a circle of 4 pieces. If you didn't get any data or any messages from the PC1 to PC2, then you will get the data from other end, like PC2 to you will get your data from to the mobile, like that. If one device fails, another device will give the data, like that. Ring topology it works. And coming to the IP address, Internet Protocol version 4. So it is a 32-bit version 4. I always wonder why it is range is 255. Why it is not more than 255, like 300 or 400? So it is a 32-bit IP address. Contains 4 octets. Each octet contains 8 bits. So total 32 bits. Yeah, 8 bits total, 32 bits, 4 octets. So it starts from range 0.0.0.0 to 255.255.255. 4 4 octets, 4 numbers. This is the first, and this IP address is divided into 5 classes: Class A, Class B, Class C, Class D, and Class C. Class A range starts from 0 to 127. The Class B range starts from 128 to 181. Class C range starts from 192 to 223. Class D range starts from 224 to 239. Class C range starts from 240 to 255. Class A contains 8 network bits and 24 host bits. So you can connect 16 million of host devices like computers to the host IP address, host bits. And Class B contains 16 network bits and 16 host bits. And Class C contains 24 network bits and 8 host bits. Class D and the Class C. Class D is for multicast, and like we earlier discussed about multicast one, like that Class D for particular reason reserved purpose only, and Class C is for research and development, like ISRO, NASA. They are using this class for IP address. And in these IP addresses, they are divided into two types: public IP address and private IP address. Public IP address is nothing but you need to pay amount for accessing that website. For private, you don't need to pay any amount. You can easily available from anywhere you can get that IP addresses. Private, uh, there are some fixed class ranges for private addresses. These are local fixed networks, fixed IP addresses ranges. For class A, 10.0.0.02, 10.255.255. Is the range for class A. And coming to the class B, 172.16.0.0.2, 172.20, sorry, yeah, 172.31.255.255 is the class B range. And coming to the class C, 192.168.0.02, 192.168.255.255. These are the fixed ranges for local, like private networks for class A, class B, class C. Now, Google is also private network, public network. And now I joined in some other network. He is also the public network. So, how can I access that without paying any money? You wonder why. So, there's a background one work is there, which is called NAT, Network Automation Translation, Network Address Translation, which converts private IP addresses to public IP address and public IP addresses to private IP. These are the we will discuss in future sessions after this. These are the things they thought of today, and I went to the institute. Again, they thought tripping, like RJ45 cable is there, yellow color cable, like we are PGs having that cable, Ethernet cable like that. They thought how we can cut that wires and how can we need to place that in order way. There is one color code: orange, white, orange, and green, white, blue, blue, white, green, brown, white, brown. This is the color coding which we need to cut and insert into that RJ45. I don't know exact number. That pin we need to pin with that, some tripping cutter. This is the thing I learned from today. Hope you got something from me. See you in future sessions.